Okay, so for 45, again, it's 4 terms like number 44, so I tried factor by grouping, and as you can see, it doesn't work out because this number times this number does not equal this. So then I have to use the p's over q's. So the p-values are plus, minus 1, 2, and 4. These are factors of 4, 1, 2, 4. And then the q values are factors of 5. So plus, minus 1, plus, minus 5. So we do p over q. So we take all of these numbers divided by all of these numbers. So that would be plus, minus 1 over 1, which is 1. And then plus, minus 1/5. And then 2 over 1 is 2. And then 2 over 5. Oops, that looks like a 3 almost. So 2 over 5. And plus, minus 4 over 1. So that's 4. And then 4 over 5. So these are the numbers I'm going to choose from for synthetic division. Now, in this problem, because of that negative right there, then pluses and minuses are possible, okay? So let me set up the first one. So I'm going to start with 1. And so you bring down the 5. 5 times 1 is 5. Then you get 24. And I already can tell that this is not going to work out because the numbers are getting bigger and bigger, right? I would need a positive 4 here, and there's no way that's happening. So I'll stop here. I'll try 1/5. 5, 19, 16, negative 4. Bring down the 5. 5 times 1/5 is 1. And when you add that column, you get 20. 20 times 1/5 is 4. And then you add the column and you get 20. 1/5 times 20 is 4. And we get the 0. So 1/5 worked. And remember, this means 5x squared plus 20x plus 20. So the first thing I'm going to do is factor out of 5. And I notice that this is x plus 2 times x plus 2, right? That gives you x squared plus 4x plus 4. And so then the whole thing would be 5 times x minus 1/5 times x plus 2 squared. So the zeros are 1/5 and negative 2. Remember, you don't have to write negative 2 twice. Once is enough. So number 46 cannot be factored by grouping because it has 5 terms. Okay, that's not an even number of terms. So you're pretty much stuck with doing the p over q synthetic division. So the factors of 16 are plus, minus 1, 2, 4, 8, and 16. Over here, the q values is just plus, minus 1. So when you take these numbers over these two numbers, you get the same list back. You get this one back, right? Because you're dividing by plus, minus 1. So your p over q values are right here. Okay? So we'll start with 1. So 1, 6. There are no missing terms, so there are no placeholders. So we try this one, bring down the 1. 1 times 1 is 1, 6, 7. 7, negative 10, negative 10. You put the answer here, you get negative 16. Negative 16 right here, and 1 works. You try it again because you don't know if it's a double 0, if the multiplicity is 1. So you try 1, and you get 1, 7, negative 10, negative 16. Bring down the 1, 8, and I can see it's not going to work because it's going to give me negative 2, and so I won't get a 0 I won't get a positive 16 underneath the negative 16. Okay, so I could either go to negative 1 or go to positive 2, whichever one. I'll pick negative 1. Negative 1. So And notice I'm using these numbers now. I'm not using the original because I'm dividing it and I'm making the polynomial like a smaller polynomial as I go through. So I'm going to use these numbers, okay? So 1, 7, negative 10, negative 16. Bring down the 1 times negative 1, negative 1. This gives you 6. 6 times negative 1 is negative 6. This gives you negative 16. And this gives you positive 16, which is 0. So this one worked. Okay? Now once you're down to 3 numbers, then remember it's x squared plus 6x minus 16. You could factor it without having to use the p over q synthetic division. So factors of negative 16 that add up to positive 6 are 8 and negative 2. So that would be x plus 8 and x minus 2. And then from the ones up here, I'd have x plus 1 for this one and x minus 1 for the first one that we found. Okay, for that one. So this is f of x. So the zeros are plus minus 1, negative 8, and 2. Okay, so we're performing we're multiplying the two complex numbers. So it's just distributive property. 2 times 7 is 14. 2 times negative 8i is negative 16i. 4i times 7 is 28i. And 4i times negative 8i is negative 32i squared. Well, I can combine these two, because they're both i's, and this I squared, remember, is negative 1. So negative 1 times negative 32 is actually positive 32. So this term right here becomes plus 32. And 32 and 14, that's, I'm talking about this 14, is 46. And then negative 16i plus 28i is positive 12i. And that's in standard form. Okay, for 48, it's asking you to find the complex conjugate of this number and then multiply them together. So first let me put parentheses around this. So its complex conjugate would be negative 5 plus radical 8i. So we multiply. Distributive property, negative 5 times negative 5 is 25. Negative 5 times square root of 8i would be negative 5 radical 8i. And then I move on to this one right here. That would be positive 5 radical 8i. And then here would be negative square root of 64 I squared. Okay, so notice how these two become 0. They cancel out. And then here I have a negative 1. And then here I have an 8. So a negative 1 and a negative 8 would be positive 8. Okay, so 25 and 8 is 33. And that's it. There's no imaginary part, just that 33. Okay, so for division with complex numbers, you multiply by 1. Now, how this one is going to look depends on the denominator. So we want the conjugate of that denominator. So that would be 2 minus 3i. So remember this fraction, the one I just added in right now, has to equal 1. So the top has to be, the numerator has to be the same. So that's 1. So now you do distributive property both on top and bottom. So on the top it'd be 16 minus 24i minus 8i plus 12i squared. In the denominator it'd be 4. Now, well, I'll write it down, but the I is going to be gone. So 6i plus 6i minus 9i squared. So in the numerator, I can combine these two, and then this 12i squared becomes negative 12. So I have 16 minus 12, which is 4. Negative 24 and negative 8 is negative 32i. The denominator, this becomes plus 9. So 4 plus 9 is 13, and this is 0. Because remember, that's the goal of the conjugate. When you multiply these two, the I is always gone. So in standard form, it'd be 4/13 minus 32/13 I. That would be your standard form. Okay, so to simplify powers of I, you take the exponents, divide by 4. So that's 2 remainder 2. 13 divided by 4 is 3 remainder 1. 11 divided by 4 is, 2 remainder 3. And then I squared is just I squared. Okay, so let's go with the first one. We look at the remainders, remember. So this means that the I to the 10th is actually going to become I squared. And then the I to the 13th is actually an I, because I'm looking at the remainders. And the negative 11 I to the 11th is going to be negative I cubed, and then here I squared. Okay, so I squared and I squared is 2I squared. And so that's going to give you negative 2. And then I have plus I, and then I squared is negative I. But there's a negative there already, right? So negative times negative is positive, so it's plus I. So the answer would be negative 2 plus 2I. Okay, so A is not given, so we're going to assume that A equals 1. So that would be x minus 3, x minus 2 minus 5i. And remember, we need a conjugate pair, so it'd be x minus 2 plus 5i. Okay, whoops. So that's x minus 3, parentheses. Then distribute this negative, so x minus 2 plus 5i. And then x minus 2 minus 5i. We're going to multiply these two together because they have the I. Again, you can do the 3 by 3 like this. So you put the x minus 2 5i and x minus 2 minus 5i. So x squared, negative 2x, negative 5xi, negative 2x, 4, and then 10i, positive, and then 5xi, and then negative 10i, and then negative 25i squared. So 5xi and negative 5xi is 0. Negative 10i and positive 10i is 0. And negative 25 I squared is actually positive 25. So now you have x squared minus 4x plus 29, because you have that 4 here. So that times x minus 3. Okay, so don't forget the x minus 3. So you can do distributive property or set up another grid, like a 2 by 3. Doesn't matter. So let's just do distributive property straight from here. So this would be x cubed minus 4x squared plus 29x, and then the negative 3x squared plus 12x minus 87. Combine x cubed minus 7x squared plus 41x minus 87, and that's the answer.